Okay, we're on definite integral. Definite integral is just the type of integral that has upper and lower limits. So whenever you see the integral sign, upper and lower limits, so we now see that is what? A definite integral. Where a is the lower limit, while b is the upper limit. So any integration that involves upper and lower limits, we call it definite integral. And once you have integral of fx from a to b is always equal to fb minus fa. You wonder what is this function f? This is just the antiderivative of f, meaning you have to integrate this after you now subtract the lower from the upper limit. Example, if you have now integral of maybe x squared, maybe x, maybe from 0 to 1 dx. So this means find the antiderivative of x, which is x squared over 2, which is now this is f here. So we now substitute the value here. So we have 1 squared over 2 minus, you substitute 0, which is 0 squared over 2. So our answer is 1 over 2. Or let me just give another one. Maybe if you have integral of 3x squared dx from 2 to 4. So we integrate this, which is 3x cubed over 3 from 2 to 4. So which is 3 and 3. So we have x cubed from 2 to 4. So this means now substitute this. Our f is x raised to power 3. So which is now substitute the value 4 raised to power 3 minus 2 raised to power 3. So that's our answer, which is 64 minus 8. So which is 56. So that's what we mean. And as you can see, definite integral is always, the answer is always a constant, meaning that we can interpret this as we can interpret it as area. So definite integral is also area. So that's it. So let's now go over to area under a curve. So we're on area under a curve. I say that area under a curve is just the definite integral of that curve from one limit to another. So I'm saying that area under a curve is just integral, definite integral from a to b of that function or curve. So example, now if you have a curve, maybe this is the curve, this fx, we're asked to find area under this curve from maybe from a to b. So we are looking for this. So the answer is just the definite integral from a to b of that function. That's the area. Or this in terms of x-axis, or if you have maybe a curve, this is maybe f of y. So maybe from c to d, we're asked to find the area under this curve. So the area is very simple. The area is the integral from c to d of fy dy. So in terms of y axis, if you have to find the area, so it's y dy. That's function of y dy. So this is just the area under a curve. So example, if someone asks you to find the so our answer, our area is just integral from 1 to 3 of x squared dx, which is now, if you integrate this, s cubed over 3 from 1 to 3, which is 3 raised to power 3 minus 1 raised to power 3 over 3. So I told you just the lower upper limit minus the lower limit, substitute the value. So which is now 9 minus 1 over 3, which is 26 over 3. So that's the answer, square unit. So it's very simple. So we have an area between two curves. Assuming we are given this graph, we are given this function. Maybe this is function f(x), y, this is maybe gx, function gx. We are now asked to find the area enclosed by these two curves. So this is just, if you notice, the point of intersection is, let's y here is b. So you now see that by observation that this is just, if you look at this first function, this function fx, if you trace from a to b, that's if you get the area enclosed by fx and you now subtract the one enclosed by gx, so you now see that this gx. So if you descend from a to b, so common sense will tell us if we want to get here, it's just if you subtract this part from the total. That's if you subtract this from the total, we get the remaining here. So which is just integral from a to b of function x dx minus integral from a to b of function gs dx, from a to b of fx minus gx dx. So that's it. So whenever you're asked to find the area between two curves, you just do the area of the one up or down, or this is just in terms of x-axis. We can still write in terms of y. Or maybe if you are given a curve, two curves, maybe this is gy, y, this is fy. So the area enclosed by this is the same thing as subtracting this is the point of intersection, maybe from C to D. So the area enclosed by this, just subtracting this, the one closer to that's the one on the left hand side from the one on the right hand side, because to get this area is the same thing as subtracting the bigger from the smaller one. So we get it that, so which is the area is just integral from C to D of the right function, which is fy dy minus integral from c to d of gy dy. So we can write the two together as from c integral from c to d of fy minus gy dy.